Hello and welcome back. We're going to talk about chapter 3 today, which is the logic chapter. This may be the first time you've studied this in a math class. I hear from students, and this is kind of a rarely studied topic in your normal, what you'd consider math class. So this may be your first time kind of seeing this, but sometimes that's a good thing because you have no preconceived notions and you can kind of just learn it fresh from the beginning. I'll try to just walk you straight through it. So anyway, I hope you like it. It's the logic section, and it's a little bit like a language of its own. It's a symbolic language for math. So on section 3.1, which this video will address, 3.1, we talk about just kind of the basics of the language we use in logic. And we'll talk about statements and connectives. So first of all, let me go ahead at the top of your note packet, if you're following along with the handout you see, we have four connectives, main connectives that we use. The word and connects two thoughts, or, if then, and if and only if. Those are four connectives that you'll see used in this section. The next thought is, what is a statement? A statement is just one thought, one individual thought, and then we'll put connectives between it and have some compound statements. But a regular, just simple statement is just expressing one idea, and that idea can be judged true or false. Some samples of that you see here, and we'll assign it a truth value, either true or false. One is the Brooklyn Bridge goes over San Francisco Bay. So we could look that up on a map. We could find out if that is absolutely true or false, and that is false. Number two, your teacher's name is Cindy Shelton. You could look that up on your syllabus. That is true. Your teacher is an employee of ACTC. We can judge that true or false. It's just one idea, and that's true. And the fourth example is Disney World is in Idaho. Again, just one thought, a simple statement, and that is false as well. We can look that up as well. So simple statements just convey one idea. Compound statements combine two or more ideas that can be assigned a truth value using a connective, such as the four connectives I mentioned, the and, the or, if then, if and only if. And again, those are called our connectives. Okay, so for example, your teacher's name is Cindy Shelton, and she is an employee of ACTC. So I'll put together two of those ideas with the connective and. A negation changes a statement to its opposite meaning. So anytime we negate a statement, if it was true, it needs to be false. If it was false, it needs to be true. So we change its truth value when we negate it. So for example, your teacher's name is not Cindy Shelton. So it went from being a true statement to now we've negated it to a false statement. Sometimes it's not quite that obvious though. If they use words like all, some, like you can see in this example, the quantifiers, we call those quantifiers, all, none, or no, and some are a little more vague. If I say some dogs are German Shepherds, okay, that is true. If I say no dogs are German Shepherds, that's not true, right? So you have to be careful whenever you're using some and none and all, and you'll see that in some of these examples. All right, so the first one, we have a statement. All math teachers are named Cindy. That's false. Not all math teachers are named Cindy. That's a false statement. The negation needs to be true. So I need to say, I couldn't say, well, no math teachers are named Cindy. That wouldn't be always true. So you see how that works. It's just not as simple as always saying none, in front, or no in front of it. Sometimes you have to be a little more careful. So again, the statement was, all math teachers are named Cindy. Okay, that's not true. So right now the truth value is false. So the negation needs to be true. So if I just say, well, no math teachers are named Cindy. If I just say no in front of it, I didn't get it. I didn't do it right. So I have to be a little more careful. So the example I put here, one way that you could say it, and there are other examples, is I said, well, not all math teachers are named Cindy. That's true. Not all math teachers are named Cindy. So just be sure, I guess the point of that is, if you're going to negate something, you need to be careful you read it and it has the opposite truth value. If it was true when you negate it, it needs to be false. If it was false when you negate it, it needs to always be true. So just read it and think about that. Another example, Disney World is in Idaho. We decided that was false earlier. Disney World is in Idaho. That's false. So I need to negate it and make sure it's true. So a negation of that would be Disney World is not in Idaho. That would work. Another example, some students have a driver's license. That's a true statement, so to negate it, it needs to be always false. And no students have a driver's license. Well, that's not true. Some do, so that would work. And again, you can follow along your note packet to see those written down. Oh, I have one more example of that on the next page. A statement, some students do not ride motorcycles. Some students do not ride motorcycles. Well, that's true. So when I negate it, it needs to be false. And an example where that would work would be, all students ride motorcycles. Okay, that is false. You know, we can't say everybody rides a motorcycle that's a student. We know that's not a true statement. So that would work. So I have some samples there and a little chart to kind of help you with that might help you to use some of those wordings whenever you're trying to negate something to make sure you get that right. True to false or false to true. All right, the next thing we're going to talk about is the symbols that we use in this section. The symbolic language. So to keep from having to write a statement over repeatedly, instead of, like I said, my name is Cindy, I could call that statement P. And so I don't have to keep saying that. Just remember statement P, and I would probably write it on the board. Statement P means the statement, my name is Cindy. So we'll use, it seems like they use P's and Q's and R's a lot in the logic chapter, so just be aware. But you can use any letters you want. I mean, in theory, we're just saying we're assigning a variable to make it a symbol. But you'll see P, Q's, R's, and S's show up a lot in this chapter. So I may decide to call my statement just a letter. Also, the symbol for a negation, I'm going to write all your symbols here. A negation, it looks like a little squiggly mark. So let's go ahead and write down these symbols for these connectives. So the negation is considered also a connection, although it just negates something, changes its truth value. But you could write that down. That symbol is a little squiggle line. If and only if is a double arrow symbol. If then is just a one arrow. Or looks like a V, and looks like it's a caret button or an upside down V. So those are the symbols we'll be using to connect things. Okay, so let P, you can see in your notes, let P equal the statement Steve is a college student. All right, if we want to negate it, so we call that P. If we want to do not P, right now, Steve is a college student, assuming that's a true statement. We want to negate that. Steve is not a college student. It would be the opposite of that. Okay, so that's the negation symbol. Note that, and I know sometimes people do talk like this, you could negate Steve, not something. If you had a double negation, that would take you back to the positive. So a double negation does take you back to a positive. If you double negate something, which we're not supposed to talk like that, right? But if you would use a double negation, it would actually make it the positive. Okay, next example. If given a negative statement like Bill is not at school, since this statement already contains a negation, it's not. If we negated that, we'd take it back to a positive. So we would normally let P represent the affirmative case. Normally, whenever we're writing it down, we let the original letter equal the positive case, and then we negate. So that's what this next note is saying. So if we're making the statement, Bill is not at school, then this statement already contains a negative. We would make P equal Bill is at school, and then say that's a not P. They've negated to make Bill is not at school. All right, so just saying, normally we start with the letter being the positive case, the affirmative case, and then we negate from there. But it could come out the other way, but normally this is standard. All right, next, a conjunction is the conjunction. Continuing on with these four main categories of connectives that we use, and then plus the negation symbol we talked about. We have some words for this as well, and you'll see that in your note packet. The word and, whenever we have an and connective, we call that a conjunction. A conjunction. You'll see that in your homework. They'll ask you if it's a conjunction or these other words. If it's or, that's called a disjunction. The if-then is called a conditional. The if and only if, the double arrow, is called a biconditional. Okay, those are the words you'll need to know when you're doing your homework that go along with that. All right, so here's a conjunction example. We have statement P, you will perform 5 months community service. That's a statement, statement P. Statement Q, you will pay a $100 fine. So if I wrote the compound statement, you will perform 5 months community service and you will pay a $500 fine, we would consider the and, so let's say that'd be P and symbol, we'd write that as P and Q, and we would say because that's a conjunction. Again, in the reading you see it use the word and, you will perform this community service and you will pay the $100 fine. It means you're going to do both of those, and means both of those should happen. All right, so a conjunction. The next one, if we were doing this P and Q, you on at the bottom of the page, a disjunction uses the word or, and the symbol is the V, as you can see up here. So if I said you will perform 5 months community service or you will pay the $100 fine, when I use the word or, it's a little more lenient. You can do one or the other or maybe both, but you only have to do one or the other to be following what it's saying, you know, following the rule of what it's saying. So or is a little more lax. You can do this or this. And again, the symbol is the V, and we call that a disjunction. You'll have homework and it'll say, is this one, which type of connective? Is it disjunction, conjunction? And you're really just looking for the words and or for what we said here. Okay? And then I have an activity for you. So I always ask you to pause the video and do the practice problems on here and then come back in and see the answers. So please do that. I'm going to keep rolling with the video though and write the answers down. So we have this statement P, and I've shortcutted it here, is Maria will go to the circus. Statement Q, Maria will go to the zoo. So write in symbolic form that Maria will go to the circus or Maria will go to the zoo. You should have said that the or is the V, so that's answer A. Answer B, Maria will go to the zoo, which is Q. So again the or Maria will not go to the circus. So they negated Maria will not go to the circus. That will be not P. So that's how that one would look. C, Maria will not go to the circus. That's the negation of statement P. Or, all these are ors, right? Or, Maria will not go to the zoo. Negation of Q. So that's how that would look. Now, moving on, sometimes they double us up on these and have just kind of run-on sentences. So when a statement contains more than one connective, a comma can be used to indicate which simple statements are grouped together. So next it says the simple statements on the same side of the comma are grouped together with a parenthesis. I think I'll go ahead and pause the video and come back in on this on the second part. So I'm going to go ahead and say we'll stop here and continue.